So let's do an example. Let's imagine that we're going to have a little cylinder and it's made of pure carbon. And let's say the cylinder has a diameter of 4.14 millimeters and it has a length of 8.67 centimeters. And what I want to do is I want to connect my cylinder. I want to connect the cylinder to a 9-volt battery, and I want to know how much current flows through it. And so you think about it and say, well, that's easy. Current is going to be, using Ohm's law, V over R. So in that case, we need to find R. We know that R is rho L over A. Okay, so R is rho L over A. Well, we've got L. L was given, 8.67 centimeters. A is going to be pi r squared. Well, r is going to be half the diameter. So that'll be 2.12. So 2.12 millimeters. It'll be half the diameter. And then we need to know rho. So rho for carbon. How do we know the resistivity of carbon? Well, we have to look that up somewhere. So 3.5 times 10 to the minus 3 ohm meters. Okay. And so we plug all this into the equation. So this is going to be 3. So this is rho L over A. So that's going to be rho L over pi r squared. So rho is, all right, it'd be 3.5 times 10 to the minus 3rd ohm meters times L, which is 0.0867 meters, divided by pi and divided by 2.12 times 10 to the minus 3 meters squared. So the resistance comes out to be 21.5 ohms. So the current, which is V over R, will be 9 volts divided by 21.5 ohms. So the current is going to be 0.419 amps. So I have my little resistor here. I made a resistor out of carbon, okay, and it has 21.5 ohms. We connect it to a 9-volt battery. We found the current. So now I want to know how much power is being dissipated in my resistor. So power is dissipated in there, which means that conservation of energy, the electrons are losing energy at a certain rate per second, and so that means that energy goes somewhere. It goes into heating the resistor. If the resistor gets too hot, it will actually catch fire because it's made of carbon. And so we know that power is I squared R. Well, that's going to be pretty straightforward. That's 0.419 amps squared times 21.5 ohms. So the power comes out to be 3.77 watts. So that's the total power being dissipated.